Hello and welcome to the second day of NDC Oslo. I hope everyone had a wonderful first day. And while I can't be with you all in person today, I'm really looking forward to sharing the next hour with you. And this will be where we'll look to solve a question facing many API developers, and that is, how do we choose between GraphQL, gRPC, and REST? So to get to the answer to that question, we're going to do quite a number of things. So we're going to start off by looking to gain a common understanding of the API styles that have evolved over time. We'll then look at software architecture and look at system properties and the constraints or decisions that then define or yield those properties. With that base knowledge, we're then going to look at a number of conversations that are happening in the API industry today and see if we can apply this learning or this logic to some of the statements that lack some nuance or some constructive element. And then finally, we're going to bring this all together and look at some sample scenarios that you may face to make it more concrete should you choose to use one of these API technologies when you either have a personal project or bring it back to your office. So before we proceed, a little bit about myself. So my name is Rob Crowley. I am the head of engineering for a company called WebHooks, and we build automated fare collection systems. So similar to the Oyster card in London, or we work with Router in Oslo as well. Before that, I was a consultant for a number of years, including Telstra Purple or Redify in Australia. And the vast amount of my career has been in building and designing distributed systems. So APIs are a subject that are very close to my heart. I'm also the co-organizer of DDD Perth, Western Australia's largest conference. And last year we had over 800 attendees. So that's really been a massive success. And I'm also available on the socials at Rob D. Crowley. And this is a talk that I've been giving various versions of for about a year now. And the genesis was really some of the challenges that I was not only personally facing, but also my clients and the companies that I worked with. And while that might sound rather altruistic, there was a slightly selfish element to it as well. And that was really a reflection that my Twitter timeline was really an absolute tire fire. And you might ask, why is that? Well, when I first joined Twitter, it was really about the same time that I started to get into APIs in a serious way. And REST was the on vogue API style at the time. So I started following many of the luminaries in the industry, such as Mike Amundsen or Eric Wild. And I learned a huge amount from these people, and it was wonderful about 3 to 4 years. And then 2015 came around, and Facebook released GraphQL. And I started following a whole host of new people. And the problem was, these two groups of people didn't often agree. So one tweet could then yield 15 or 16 rebuttals or counter-arguments. But many of these counter-arguments were very black and white. X is better than Y, or Y breaks this. And I found it very difficult to then take that information or take that statement and then apply it to the problems that I was facing. So I'll share a small example of what I saw there. So back in 2019, on May 25th, actually my birthday, I saw this tweet and it was like, it's 2019, you should learn GraphQL. This was very much the same time I was playing around with quite a lot of the real-time subscriptions elements of GraphQL. I said, absolutely, this is something that we should have available to us. So I agreed with him quickly. Aaron, he is one of my good friends, but one of the cloud advocates at Microsoft. It's just fancy OData. And that again is one of the playful exchange. We do see more serious versions of that going around. And I would like to comment that actually this weekend, Aaron will be building an app with GraphQL. So I think in the long run, I might well have won that argument. But it's not just happening on Twitter. So if we look at some of the blog posts that have been shared, as I say, sort of back in 2017, so a couple of years after GraphQL got released. And there was really a sense there that it would completely eclipse REST. And this particular article says, REST is the new SOAP. In other words, we won't need it anymore. It's dead, defunct. And again, I found this quite confronting because I had spent the last 10 years of my career learning REST APIs and learning how to build effective, how to design resources and workflows. Is all this learning now defunct, not required? And this isn't an isolated article either. Another one from about the same time declared REST APIs are rest in peace. Long live GraphQL. Again, more sentiment from the community that there was only one way to build APIs moving forward. And I personally didn't see that that was the case. And I saw many of the clients I were working with had the same problems and were facing the same challenges. And it wasn't just these conversations. I had this sense of deja vu when I read a lot of these articles. And I couldn't help but feel that we've actually been here before. So if that's what was happening in 2017, let's wind the clock back a little bit further and we'll go back to 2010. And in this case, we could see the same sort of articles, but this time declaring REST being in the ascendancy and SOAP again going out of favor. And this one that says SOAP is officially dead, long live REST. And the unfortunate truth is a huge number or percentage of the APIs we deal with today in production, they're still SOAP-based. While it mightn't be on vogue to build new APIs using that today if we have other choices, it is definitely not dead, and many of us are still supporting APIs in many different technologies. But what can we really take away from this? So if SOAP is dead and REST is the new SOAP, does that mean GraphQL is the new REST? Surely not. That couldn't be the case. It wouldn't make any sense. But lo and behold, yes, it is apparently. GraphQL is indeed the new REST. Part one. I'm not sure if there was ever a part two, but if there is, please let me know. So what can we actually learn from these exchanges? The first thing that we would have seen is that they're all very black and white. They all have one view and don't really take in a lot of possibility for an alternative. So maybe we can dismiss all of this and simply say, maybe we just don't like XML and we get on with it and we look at different challenges. But to do that, I feel, would miss a very important point. And that is that many of our API consumers, the very people we build APIs for, and again, something that's close to my heart is we build APIs for other developers. So many developers are unsatisfied and frustrated with the APIs experiences that they're experiencing or receiving. And also our API community is very small. We need to work together, so we can't really afford to have these camps with different ideologies or different views around certain technologies. So what I'm really hoping from today's talk is that I can give you the necessary foundation of understanding that you will be able to take a balanced approach to choosing the API's technologies and styles for the problems at hand. And maybe that sounds a tiny bit idealistic, maybe a tiny bit of a dreamer. So we could imagine that there's no protocols. It's not hard to do. Maybe there's no hypermedia hills to die on, no media types. We don't have to worry about contracts. Wouldn't that be wonderful? Unfortunately not. That's not how APIs work. APIs are required to allow two parties that are otherwise distributed to communicate effectively. We will never get away from having to have shared semantics and also shared syntax. So we cannot just understand what's meant by the message, but also how to decode and encode that message. So we have to have standards and protocols. So this is a problem that we need to face into. So let's see a little bit about how these technologies or styles have evolved over time. So I'll take us all back to 1991 And we'll start with Corba, so a middleware language. And at the point in time, this was really seen to be the future of e-commerce on the web. Unfortunately, for some, it actually fell out of favor for XML of all things. Moving forward to 1993, we had remote data access. So a client-server approach where a client could then query data from a remote database. So it sounds very like a query syntax, and it was. And we'll see some similarities in that approach as we see some future API styles and technologies. So moving forward into 1998, we had a formal specification of XML RPC, and RPC stands for Remote Procedure Call, and it is a term coined by Bruce Nelson. But up until this point, RPC was an approach, but there wasn't a specification around it. So in 1998, we had a formal specification for doing RPC over XML. In 1999, Don Box and 4 others from Microsoft, and the name Don Box might be familiar as the man behind the 4 tenets of SOA, and they released SOAP. So again, a heavily RPC-based technology, which then used a WSDL as the contract that would then format the exchange between the client and the server. In the year 2000, Roy Fielding released his seminal dissertation about REST, and this was really about building APIs that didn't work orthogonal or against the web, but really embraced it. So how can we build APIs that are sympathetic and embrace the underlying protocol? And this is mainly for the purposes of the APIs we'll be talking about today, HTTP. Moving forward to 2005, and in this period, REST really begins to rise to the ascendancy in the APIs that we're building. And we still have RPC, but at this time, we've seen XML give way to JSON. And that's really keeping in sync with what we saw with the move to REST as well. Moving forward to 2007, we had OData, another technology released by Microsoft under the moniker of a better way to REST. And this really embraced a lot of the ideas of remote data access, where it provides a rich query syntax for the client to define exactly the data that it needs from the server. So instead of a uniform interface constraint, which defines a canonical URL for each resource and in which we will then receive a representation back from the server, this then provides a huge amount of data to the client to define exactly what it wants in the shape. So moving forward from 2007 to 2015, GraphQL lands on the scene. And again, this is really about empowering clients to receive only the data that it wants and avoid some of the perceived inefficiencies around REST. And then in 2016, we've got the latest incarnation of gRPC. And that is, again, RPC going back all the way we saw back in Corba in 1991. And while the approach remained consistent, we've seen the implementation of the technologies change over time. So if that's the technologies themselves, what can we see that has been happening in parallel within the industry? So in the early 2000s, we were really building APIs for specific partners, and they were stovepipe integration. So one-to-one, one client going to one server, and it's a discrete integration. This really changed with Web 2.0 starting in about 2010, when companies like Twitter and Facebook start building public APIs. And these are APIs where one server can support multiple different clients. But instead of it being built for one specific client, it's more of a conformist API, if you are aware of Eric Evans and domain-driven design, where they don't take into account individual client needs, but rather define an interface which we all conform to. And this has really been the prevalent style for public APIs for the last decade. And then where are we going to see happening next? So there's quite a lot of people in the industry saying that the next wave will likely be autonomous APIs. So rich lattices of APIs that will then be composed to achieve higher order business needs. And this will be underpinned by technologies like serverless as well, which reduces the footprint and will move to a more worth-based model for APIs. But this is still some ways off, and the majority of us will still be in the second wave of generic APIs, particularly if we're building public-facing APIs or APIs for multiple internal teams within your organization. So across all of these technologies, while they might appear relatively different on the face of it, they all share a surprising number of commonalities. So we have flat file APIs. So an example of this might be electronic data interchange. And while it might sound antiquated, it is a perfectly valid and in fact ideal choice if you were doing large batch operations. This is maybe month-end reporting. And instead of sending a paper-based file between two companies, you can do that electronically to a defined format. And if that's a batch style APIs, the complete antithesis of that is a streaming API where we're constantly exchanging data between the client and the server. And that could be stock price changes, or it could be video or data streaming. We have RPC APIs. So most recently brought to the fore again by gRPC, where with an RPC API, we are effectively treating the distributed call almost as if the network was not there. So we're treating it at a higher order, and we're trying to keep the semantics of that higher order language as well. With a web API, how we call and consume data is very different. So instead of using classes that abstract away the network, we actually spin up a HTTP client. We embrace the web. We send HTTP methods to define, again, what operations we would want, again, to a specific URL. So we're really embracing the web with that. And that's the major change or difference between the experience of calling and consuming an RPC or a web API. And I'll ignore the semantic or design changes for this particular point in the talk. And it might be a challenging message to hear first thing on the second day of NDC Oslo, but there is no single best API style. Computing is hard. Building APIs is challenging. What I can say, though, is there is absolutely a best API style for your problem. And that is really the purpose of today's talk, to arm you with the information required that you can first define or identify the appropriate style, and then the technology for your own problem at hand. So how might we go about being able to inform ourselves about this decision? And we can take some guidance from Roy Fielding. He said that the properties are induced by the set of constraints within an architecture. So in other words, the design choices that we make will then yield certain characteristics of the solution. And when we think of constraints, we often just think of technology constraints, but there's many types that we really need to consider to build an effective product. There's business constraints. So anything that really affects the profitability of a company or business endeavor. So that could be time, could be financial budget, and this could be across your customer, your own business, or certain product requirements. Maybe you're just looking to have a very perishable window of opportunity, and that's a severe set of maybe time constraints on what you can do. Then there's technical constraints. So embracing all the challenges of distributed computing. So we have the 8 fallacies. So the network is not reliable, latency is not zero. So what are all the things we need to do to support maybe the security concerns or delay that we're facing? but also how we need to be able to evolve the system over time. And the final, and probably the most interesting set of constraints is all around the operation of that service. And this is really all the socio-technical or the human constraints around. So how are we going to support or build this system? Is there multiple teams within an organization building it? In which case, then looking at Conway's law, which states that the systems we build will be a mirror of the communication pattern between our teams. So these are things that have become very close to my heart in my current role, where I'm looking to align the operating model again with the product lines that we're looking to build. And it's not just about organizing teams, but it's also about the set of knowledge or expertise within your teams. So for instance, REST, to build an effective REST API, requires deep expertise in HTTP. And if you don't have it, you will struggle to be able to get the most out of that API style. So again, really looking at all of the elements around your teams, how they're organized and the knowledge they have to drive some of these decisions as well. And so when we take all of those constraints, be they business, technical, or socio-technical, they will then yield the properties of the system. And that will be the properties of the software system itself, but also the wider ecosystem, everything around the operation of that product. And when I'm designing a system, I always start with the properties. I define the characteristics that the system needs to have, or the properties it needs to display. And then I work backwards to say, what constraints or decisions can I make that will then yield those properties? So it's always a case of defining what you need and then working back. It's definitely not a case of starting with a technology and hoping it will fit your problem. So how might we gain some insight into being able to do this in practice? And again, Roy Fielding has some interesting guidance for us in this case. He says that while there's never an optimal architecture style for every application, we can start comparing architectural styles by the properties induced. And this was really the original premise for this talk. And I was slightly dismayed to learn 5 minutes into my research for it, is that someone else has actually done it. So Zenacademic gave this talk, or a very similar detailed review of REST and GraphQL in the end of 2018 at Nordic APIs conference. And he goes into quite a lot of detail about the pros and cons of different API styles, particularly in terms of REST, which I would say he started with and then started to compare GraphQL with. It is a very insightful talk. I'll include a link to it in the references that I'll share at the end. But it doesn't cover gRPC. So over the course of the next talk, we'll weave in some of the insights that Denick had, but then also update where we've sort of seen over the last 16 months, 18 months since he gave that talk as well. So instead, we're going to look at something that's a little bit more fun. So we're going to look at some of the conversations that have been happening in the API industry over the last sort of year and a bit. And then we're going to, for each of those statements, we're going to take the next level of detail to it and then start dispelling some of those myths. And at the same time, using these as the vehicles for comparing different aspects of these API styles and showing where some shine and where others don't. So let's tackle the initial ones that I mentioned at the start of this talk. And that is the statement that REST in peace APIs, that REST APIs are REST in peace APIs and long live GraphQL. Or as another person put it, GraphQL will do to REST what JSON did to XML. But they're blanket statements and they don't let us know why or any context or supporting that statement. So let's start by looking at some of the thinking that underpins these API styles. So GraphQL on the read side, so where the client is querying data from the server, looks very like RDA, so remote data access. It affords a huge amount of power to the client to request the data and only the data it needs. However, on the right side, it uses RPC, and that's for the mutations, so that's again a write, or subscriptions, which are an event-based way of getting real-time data in GraphQL. So we can see actually that GraphQL heavily builds on the API styles and previous approaches. And in fact, it's also got a fair amount of HTTP semantics woven into it as well. So let's compare GraphQL then to gRPC. And gRPC is quite different. GraphQL and REST are both protocol agnostic, whereas gRPC is firmly tied to HTTP2. Not HTTP 1.x, but specifically HTTP2 to support multiplexing across a single connection. And this is really where gRPC is focusing on, is about performance. So again, being able to have very performant real-time interactions across different distributed components. And if HTTP2 is the protocol, gRPC then uses protobuf or protocol buffers for both the contract, the interface definition language. So in the case of SOAP, this was WSDL, or in the case of a GraphQL API, that is the GraphQL schema. And in REST, it could be an Open API Initiative contract or RAML or API blueprints. So it uses protocol buffers for both the contract, but also as the data exchange format across the wire. So how we encode and decode data. And REST is something very different again. So if gRPC and GraphQL are data over HTTP, REST is really a state machine over HTTP. And when I say state machine, what I really mean is workflow. So it could be a business process, which based on what stage in the process you are, you could have multiple different actions or paths that you can take. And state machines then are driven by an aspect of the uniform interface constraint, which is hypermedia. And hypermedia is often one of the things that we struggle to understand in a REST API, or how we can build those affordances into our responses. But it's actually a concept that many of us are already familiar with. So if we take a look at this very basic web page, what we can see is there's actually a number of hypermedia controls already. We have an image tag, an anchor tag, and a form. And all of these controls have well-defined semantics, which then allow any browser to consume this page and know what to do with the data. So an image tag, when the browser receives that, it will dereference the resource that is mentioned at that URL, and it will then display that within the allocated space in the window. When you click on an anchor tag, that link will be dereferenced and you will be navigated to that particular page. And with a form, when you submit that form, all the data will then be packaged up and sent to the server. I talk a lot about hypermedia because I do feel it is absolutely foundational to building a REST API. And while we often see it at the top of the maturity model at level 3, for me, it's either REST or it's not, and that is defined by whether it is ATOS or not. So hypermedia is the end of the application state. I don't mean this to be a confronting message. I apologize if it is. But I firmly believe that where we don't embrace hypermedia, we end up with a lot of REST-ish APIs that are difficult to consume, but also require a fair amount of knowledge to build. And I firmly believe that in many cases, those APIs would be able to be built more effectively or deliver a better experience, maybe using one of those other styles, if again, from a socio-technical constraint, we don't have the knowledge to be able to get the most out of that style. So really, don't build REST-ish APIs. There are many options that we have available and many different constraints that will then be able to yield the best outcome for our consumers, which is really the goal in any API that we build. And while that as I mentioned, might be a tiny bit confronting, I hope it's not, because there is no best API style. So if your API is mostly actions, then RPC is actually a brilliant choice for it. But we shouldn't start saying, I want to build a gRPC API. So a great example of a public RPC API would be the Slack API, for instance. However, if an API is mostly CRUD or manipulating related data, maybe with a workflow, then REST is a fantastic choice. And Phil Sturgeon, the person who I've quoted here, writes a blog, APIs You Won't Hate, and he has a wealth of knowledge to share on this subject, so I would encourage you to follow him as well. And even one of the authors of GraphQL, Lee Byron, stated that GraphQL is not the optimal choice for all scenarios. It is very much focused on client-server, where the clients or multiple clients have very different data requirements. For server-to-server communications, there are better choices. That's where gRPC shines, or Thrift from Twitter, and even REST APIs in simpler cases as well. So again, understand the context in which you're in. So wrapping up, API styles address different problem spaces. In some cases, REST-ish APIs, which I feel have been responsible for a large amount of the backlash against REST APIs, would actually be better built in other styles. Not because those other styles are inherently better, but some require less of a ramp-up time on behalf of the development team. And gRPC is a perfect choice for synchronous communications between internal services. So where your domain requires very frequent data updates and potentially different interactions rather than the client-server call that you might see with a REST API, but supporting other scenarios such as streaming data from the server, where one call from the client can result in multiple responses from the server, or vice versa, where client streaming, or in many cases, bidirectional streaming. So again, different styles and different technologies support the different areas of your application. So moving on to another comment that was coming up quite a lot in sort of at the start of last year. It's died down a little bit, but there was this view that GraphQL breaks caching. And the first question we should really think about is, what type of caching? Because there's many, does it just universally break it? I'm not too sure. So this client side, so that might be in the browser, or in the case of GraphQL, in the denormalized client cache. There's on the server side, also known as application caching, or intermediary caching proxies such as Squid, Varnish, or Nginx. So let's take a look at this in a HTTP context. So in addition to client and server side, you can have intermediaries, which will then be able to hold that data between the clients and the server, reducing latency. And while we can do that for HTTP, that's not an option for GraphQL or gRPC. So while you can still handle data on the client and on the server, the intermediate options are not there. And that's really about how they use HTTP across the wire. So posts, for instance, which are typically used by GraphQL, are not cacheable by default, not by the intermediate proxies. And why could that be an issue? Because while the speed of light is very fast, about 300,000 kilometers per second, it's not infinitely so. So typically, if you can get your data closer to the client, they will get it faster. And where there's a will, there's a way. The GraphQL community have looked at options about how to support intermediary proxies. And they've taken a look to be able to use the get HTTP method along with persistent queries. And persistent queries was really championed by Apollo, one of the vendors or producers in this area, particularly in the node space. And that is, instead of the client sending all the data to the server, the entire query, rather this query is stored on the server, and then just a query ID is sent across, and then that query is hydrated on the server before being executed. And with that, we can get back to using a HTTP GET method. But there's not a standard around here, which is a shame, because that was really what simplified a lot of GraphQL development. Instead of REST, which was an architectural style, and a lot of the implementation was left to the development teams, hence the large ramp-up time that I spoke about previously, GraphQL eliminated a lot of that by providing a concrete specification to work from. But there is no GraphQL specification for operating over HTTP. There are a few unofficial ones, but nothing that can really bind the community together. But it's not just about intermediary proxies. There's also other aspects to consider. Authenticated traffic, so for instance, any traffic with the authorization header that might contain a API key or a bearer token, will not be stored by default by shared caches. And if this is a case where all of your data is personalized or tied to a specific identity, this changes your problem domain quite a bit. So maybe you wouldn't have used intermediary proxies at all. So again, consider that in your domain, that whether the traffic is anonymous or whether it's always served to a specific client. There's also other aspects, such as the more customizable you make an API, in other words, the more power you give to the client to define the data that it needs, the less cacheable it will become. So in REST, when you have /customers/5, that is very cacheable because there's nothing else you can do with it. The second you make it more flexible, you are reducing the likelihood of a cache hit. So wrapping up, there's many different kinds: client, server, and intermediary network. Be aware which ones are powerful in your context. Highly customizable APIs benefit less from intermediary proxies. And if they are valuable, then REST is a brilliant choice. And best practices are still emerging for GraphQL and gRPC. Another comment which I found quite amazing was the view that REST APIs are inefficient. And what do we really mean by inefficient? Because in many cases, REST was never about short-term efficiency. Rather, it was about longevity, long-term evolvability, and evolution of a client and a server, which aren't tightly coupled together. So I think in many cases, when we say inefficient, what we actually meant was performant, so that there was performance issues. And typically, this was the result of overfetching or underfetching. So overfetching is where we would retrieve far more data than we required, potentially wasting expensive data plans, or underfetching, where we had to make multiple calls to the server to retrieve the data that we need. And yet we have techniques for this as well. So we can use sparse field sets to address overfetching, or compound documents, such as defined in JSON API or HAL, Hypermedia Application Language, in those media types to be able to type multiple responses together or representations in a single envelope. And this is really where GraphQL was first positioned. And that was being able to allow any client to retrieve exactly the data it needs in a single round trip to the server. However, there's an implication to this, is that the slowest field now dictates the overall response time. And this has always been the case with any API. But with GraphQL, giving all that power to the client to build up arbitrary depth queries, we are compounding that effect quite a bit. So in fact, all the data might come back in a single call, but the time the client needs to wait for all that data to respond can actually be quite high. And when I first started getting GraphQL APIs into production, that performance tuning of queries became a significant overhead to my teams. And again, there's been certain movement in the industry to try to overcome this. So using deferred queries, where parts of the data will be sent back to the client initially, and then HTTP patches for subsequent parts. But it all adds complexity. And what we really should be asking ourselves now is, should it be this complicated? Should it really be this hard? And HTTP2 has really been a big game changer in this area. With HTTP 1.x, we use many hacks to try to overcome some of the cost of a connection. So be that the TLS handshake or the TCP handshake or window scaling needed, but we ended up with typically very poor connection reuse, and then the high cost of a handshake quite often in our APIs. Whereas with HTTP2, we can have long-lived connections and all of those communications between the client and the server happening over a single multiplex connection, removing a lot of that cost or waste in doing multiple calls. So in fact, looking at compound documents and in fact, being able to pull back all that data in GraphQL in a single call is very much a double-edged sword. If we could make separate calls that didn't have a performance impact, then that's actually a far better outcome for us, because we still get all of the caching semantics we would want from the discrete calls, but not the performance hit of making multiple calls. So it's a win-win. There's other aspects to HTTP2 as well, such as server push. And frameworks or open source projects such as Vulkan actually embrace server push to be able to then have the server proactively push additional representations to the client, even without the client asking for it. So again, being able to, if you retrieve the master, automatically push the child resources to the client because the chances are they will need it. So that's quite a powerful approach. And while it never really gained traction in the web space because prefetch links with general directives were generally easier to work with, it's showing a lot of promise in the API space. So performance. In HTTP 1.x, the cost of a handshake was very high. And that is both at the TCP level, but also at the TLS level. And HTTP removes the need for compound documents by actually reducing or avoiding the multiple handshakes that would have been required in 1.x. And server push creates new possibilities again. There's still certain issues with efficiency and the fact that all of those push representations live within the HTTP2 connection rather than the other caches on the browser. So again, if that connection dies, so does that cached copy. And there's other aspects such as cache digests that will be able to allow the clients to say, don't push these because I already have it. So it's still an emerging technology and approach. And gRPC heavily uses HTTP2 for that multiplex connections for the streaming operations that it supports. But then does HTTP2 make GraphQL irrelevant? So again, if GraphQL was all about compound documents, supposedly, do we need it anymore? And again, GraphQL is not just about network efficiency. And I feel we'll see as a community this starting to become less and less important as we move forward. But the value of a technology is actually the sum of its parts. So again, as I mentioned before, all the other constraints, it's not just about the technology, it's about the ecosystem and the tooling. And GraphQL offers an incredible developer experience. You can get very good documentation out of the box using generation. And it also comes with a wonderful SDK. So again, how actually people consume it. And if you look at an example for this, in V3 of its API, GitHub had to support multiple client libraries or SDKs for many different languages. With the power of a GraphQL specification, with V4, it didn't have to do that at all because the community could build GraphQL client libraries or SDKs that would then support its API without having to do that work themselves. It also allows developers to use that tooling of choice to deliver an excellent developer experience. So when we're choosing a technology, think about all of the facets of the ecosystem around it. So again, the true value of GraphQL and many technologies lies in the tooling ecosystem and not just the immediate technology itself. If you're only concerned then with network efficiency, then a HTTP2 endpoint might be a great choice for that because compound documents are no are no longer the only option we have for improving network throughput, but this story is far from finished. Another one of my favorites is GraphQL supposedly eliminates the need for versioning. However, there was never a need to version your API. It is a strategy for decoupling a client from a breaking change in your API. It is a strategy for compatibility, not a requirement. And it's not the only option we have available either. So we have versioning as being one, but we also have graceful evolution. And when Roy Fielding was asked, how should you version a REST API? The simple answer was, don't. And in fact, this is exactly the same view that the GraphQL designers took as well, favoring graceful evolution through the deferred attribute or directive. And to my mind, graceful evolution should always be your goal, but it does require discipline. So for instance, we can't add required inputs. We can't make outputs that were required, make them optional. We can't remove them. We can't change the type of a field from a number to a string. And we should always follow the robustness principle of Postel's law. So be incredibly broad with what you accept, but incredibly specific with what you send. And this requires discipline. And I guess the key thing there is don't rely on graceful evolution alone. Not over-communicate with your users around these changes. So it's not enough to say, in my mind, to put a deprecation or a sunset header in your API responses and then have your API consumers update automatically. Send out a bulletin, let them know what will change, engage them, let them know how long the window is that you can support them. Particularly important when you're building APIs for internal teams in your organization, but that still adds a lot to the developer experience of making your API a joy to use. And it's not just on the server side. So clients also need to have discipline. So tolerant reader pattern, as defined by Martin Fowler in the Enterprise Integration Pattern book, is again how clients should respond to APIs. So don't deserialize directly into classes. So if the fields appear in a different order, don't break. If additional fields that you aren't interested in appear in the response, again, don't break. So apply the tolerant reader pattern. And that's what allows both the client and the server to evolve independently or more robustly. And GraphQL makes this an inbuilt feature. So it makes deprecations through the @deprecation directive. And when I first started using GraphQL, I thought this would be incredibly powerful. Instead of doing broadcasts to say, this field might change, who would be interested, who should I engage with? Because I know every field that every user is requesting, I'd be able to have specific conversations. What I found, though, is it doesn't take long until everybody uses something. So you're always dealing with, if you have to introduce a breaking change, really going through the same steps you would have anyway. And it's not just about the contract level. There's also certain inbuilt behaviors in your API about performance, for instance, which, while they're not defined in the contract, there's absolutely other people relying on it, particularly if you've got multiple APIs that you might have daisy chained together, ignoring multiplicative effective downtime. And then latency becomes a big issue across those services because we want to tune the timeouts. So even if we're doing a refactor as well of some of the behavior, in many cases, understanding that you shouldn't really fix or change a behavior, and many of those behaviors cannot be defined in the contract alone. So again, communication with your users becomes incredibly important. So how might we go about being able to create our solutions that can evolve gracefully? And this is really by embracing the interface, which in our APIs needs a contract-first design. So in GraphQL, it's the schema, it's the protocol buffer, or again, the OpenAPI, RAML blueprint, etc. definition. And once we have that shared understanding around the interface, both the client and the server team can work independently using mocked stubs against that interface. Finally, you can integrate, and the whole loop repeats again. So if you're not using a contract-first approach, particularly when you want to be able to build things in parallel, I would encourage you to investigate the approach. It is incredibly powerful to be able to iterate a contract very quickly, rather than having all the code that you need to change. So when you're designing your API, the later you can write the code or the higher fidelity, the better outcome you're likely to have with less friction. So versioning, it's a technique for managing breaking changes, never a requirement. You can do that for any of the API styles that you can support, but again, prefer graceful evolution if possible, but it requires both the client and the server to adopt those robustness patterns. Absolutely not a substitute for communicating with users, and it doesn't protect your users from depending on implicit behavior or non-functional requirements. The final one we'll look at is domain modeling is purely a REST concern. That's absolutely not the case. We have to embrace software architecture design and understand their domains irrespective of the APIs or the styles that we use. And we should always start with the user's front of mind and work backwards. So what's the experience we need to provide? And then how might we go about designing that? So again, the contract is a great way to be able to do this rapidly. And while both gRPC and REST start with an outside-in approach, GraphQL changes it a little bit, whereby we build a graph and then which depicts all the data that can be queried, and then the client projects its queries onto a certain portion of that overall graph. So the side effect of this is GraphQL actually allows you to delay the last responsible moment for what the optimal queries are until the users start using your system. So you don't have to iron out exactly what endpoints they will have because they can define the shape of their own data. The trade-off with that is, again, performance tuning gets pushed to the right in the process. So API designs. So API design skills absolutely table stakes irrespective of the style. You have to understand your problem domain. Both REST and gRPC follow an outside-in design, so starting with the experience, define your endpoints, define your operations in the case of gRPC, and then work backwards. And GraphQL delays this moment until profiling queries. So if you have a domain and you don't have a great understanding of potentially multiple clients that need very different data, rather than creating bespoke BFFs or different endpoints for each client, GraphQL allows you to support that in a fairly elegant manner, albeit just at, in my experience, the cost of some of the greater operational overhead of it. So with those conversations understood, let's actually look at some sample scenarios in the final sort of 7 odd minutes that we have together, and look where I would be looking to apply one of these styles. And the tenets I would always have, as I mentioned before, start with the properties and then work backwards to the constraints. And one of those things, always keeping simplicity in mind. So what's the simplest approach that you could take to solve this problem, rather than a technology approach trying to fix the problem? So if you're just building a basic application web form, maybe just a single client, that web page, we use all the data and all we're doing is posting it to the server, there is no value at all in using anything more complicated than just a simple HTTP post. Keep it simple. Don't say, but I might need more functionality in future. That's fine. It's very easy to change it, but keep your landscape as simple as possible. Both you and maybe the person who supports the code base after you will be thankful of that in the long run. Where GraphQL does absolutely shine is at that composite API level. So maybe you have a suite of APIs existing within your company, and maybe there are many different technologies and many different clients requiring different data. And maybe there's multiple round trips to the server and performance is an issue. Very much the same challenge that Facebook were facing when they were creating GraphQL. Then GraphQL does give you a second chance to build the API you wish you had built originally. But it only gives you one chance that can then act as a facade to those downstream services. But it does not absolve you from really understanding what those data needs are. But GraphQL is absolutely agnostic of the underlying data source. It could be another service, it could be a database, it could be files, it could be another web service. But it does provide an incredibly powerful common interface into data, whether that data exists on the client, on the server, you want to interact with it in a real-time or a request-response unary type style. So having that single interface into your data, particularly when you have multiple different types of clients, can be very powerful. Something I've been using quite a bit with my teams as well is the sort of the BFF style for mobile apps. So instead of having many responses going back to the client and having to stitch all that data together, really use a BFF. So backends for front-end pattern to extend the application boundary to the API as well. And gRPC can really shine in this area because what you can then have is a single technology that can support all of the APIs that you have. So you can have incredibly powerful code generation for protocol files defined and then code gen in any number of modern languages. And having a very simple way of then testing consistently across your entire landscape. So we've seen that with certain clients that have then simplified their architectures a lot by being able to choose one style and really optimize their teams for how to build and release those APIs. And again, gRPC is great when you have highly, I would say, temporally coupled APIs, particularly microservices that all need to exchange data in a real-time basis. And gRPC, again, is perfect for that. But there's certain scenarios which we can't support. So for instance, gRPC cannot be used natively in a web browser. We simply do not have access to the low-level frames in a browser that's required for HTTP2. Likewise, we can't support gRPC hosted on ASP.app services. We don't have access to some of the trailing headers that we need. So even though we can support HTTP2, there's certain aspects of that protocol that aren't supported. So again, what the industry have done in this area have come up with a companion protocol, gRPC Web. And that's effectively a way of doing gRPC over HTTP 1.x in a compatible way. But if we're going that from a client, you typically need a proxy that will then convert the HTTP 1.x traffic to 2.0 for your internal services. And typically that would be Envoy, is what I've used before. So the sidecar technology from Istio, which you might be aware from it. But there's also experimental technologies from Microsoft, from James Newton King and co, which allows you to run that on an app service without the need for a separate proxy. So again, as I mentioned, there is an option there, but it is experimental for now rather than a finished product. But I do understand that Microsoft are committed to it. So, takeaways. You would have seen that there's many different API technologies and styles that have evolved over time. While they appear very different initially, they actually come back to a number of core styles, each which support or are aligned to a certain set of problems. We then saw how you can start looking at the properties of your system, then working back to the constraints that would then help deliver those properties or characteristics. From there, with that knowledge, we then started to look at some of the conversations which are happening in the community, and then being able to look at those statements and then apply that constraint and property thinking to understand what's actually important in your domain. And then finally, we looked at just a few real-world scenarios, which hopefully got you thinking that maybe this is similar to something that I've been building myself. That will give you some guidance to be able to understand where you should start your journey when you leave or get back to work from NDC Oslo. So thank you so much for choosing my talk this morning. It's been an absolute pleasure being able to share some of my experiences with you. If you're looking to download any of the slides, they are available at this URL. Once you download them, you will also gain access to all of the resources that I used in the creation of this talk as well, such that you'll be able to get that next level of detail as well. So thank you so much for your time, and I hope you have a wonderful remainder of NDC Oslo. Thank you.